All right, so why would we actually need a dynamic number of something coming from the user? Well, in the last example, I showed you the sum function. That's a pretty natural one. But in finance, we also could think about an NPV function, right? We don't know exactly how many cash flows we're going to be modeling in our NPV analysis. So we need our function to be flexible enough to take, 2 cash flows in, 20 cash flows in, however many the problem calls for. So in this example, we're going to start with the NPV function that's built into Excel, and we're going to build our own NPV modeling functions as well. So you can see that I've actually already calculated, using the NPV function here, the NPV of these cash flows from year 1 out to year 5. Just to refresh you, the inputs to the NPV function are first the discount rate up here in C2, and then the series of cash flows. Importantly, you'll notice I've left off the time 0 cash flows. And the reason is the way the NPV function is built is whatever the first value in that array is, it's going to discount 1 period. In this case, 1 period at the discount rate of 15%. So it always assumes that that first cash flow is 1 period away. We're going to do the same thing when we mimic ours. We're going to just add a little bit more flexibility, and we'll do that in just a couple minutes here. All right, so that's what we're trying to emulate. Again, we don't know how many cash flows the user is going to put in, so we're going to have to figure that out for ourselves using that ubound function. So let's go start building this over in VBA. All right, you see we already have a little bit of code that we built in some of the previous videos. Just in case we need to remind ourselves how that ubound works, we're going to be using that in a second. But let's start out defining our function. We're going to call this NPV Modeling Horizontal. And now let's do our input variables. So our first input, we're going to use our discount rate as a double. And then we're going to do our cash flows as a variant. All right, so importantly, that cash flow is a variant to allow different sized arrays to come in from the user. So let's hit enter. We're going to copy that function name. You can just do a kind of dummy holding variable for now. Just set that equal to 1. Now, because we want to use cash flows as an array, the first thing that we want to do is set cash flows, our variant, equal to cash flows, which again tells VBA that it's an array, and we can now work with it as an array. All right, so that's our first necessary step whenever we're using kind of an array as an input. Now let's initiate our other variables that we're going to need. So we're going to want a variable, we're going to call it answer, and that's going to keep track of kind of our cumulative answer of the value, basically the NPV value that we're going to accumulate over time. So we're going to initiate answer as a double, and I'm going to dim I as a long. All right, here I'm going to use I as kind of that traditional looping variable. I've told you in the past how I like kind of explicitly named variables where you say, loop num, for example. I'm going to use I here just so you get used to it. You're going to see it in practice at some point. So I'm just going to show it to you here. So again, you're just more familiar with it when you see it in the future. Also, I'm going to use it as a long, which basically is a big integer. It just allows for a little bit bigger integers. We don't really need it here. I just want to use it so, again, you're exposed to it and aren't kind of wondering what that is when you see it in the future. So I've set this up basically to start building essentially a loop to where I can loop through each of my cash flows and discount them the appropriate number of years. So let's set up our loop for I equals 1, 2. Now here's the question, how many times do I want to go through the loop? Well, I don't know from the start, right? I don't know what the user gave me. And this is where that ubound comes in. All right, we're going to say ubound, and cash flows is what the user gave us. And now we have to ask ourselves, do we want the number of rows down or the number of columns across? Because this is NPV modeling horizontal, we're going to assume it comes in as a horizontal array. So we want the number of columns. Again, rows, columns. So rows is 1, columns is 2. So cash flows, comma 2 tells us ubound cash flows, comma 2 tells us how many columns are in the array cash flows. All right, that's the whole reason we're building ubound, so we can figure out how many times to run our for loop. We're then going to finish it off with a next I. All right, so we've structured our loop. Let's just make sure it runs through this thing 5 times right now. So let's go debug dot print, and let's just print out I. Right? I just want to see I each time through the loop. So let's go over to our function here. NPV Modeling Horizontal. Let's put our parameters in here. Just like our NPV function, we're putting those in. Sorry, I forgot to lock everything. And we get the value of 1, right? Remember, that's how we hard-coded it in at the beginning, so that's okay. Let's go see what our immediate window shows us. So here we see 1, 2, 3, 4, 5 in our immediate window. It looks like it worked as far as giving us out I each time through the loop. So let's go ahead and delete that, clear that out for later. So we can comment that. And now let's actually write what our code should do. So we start out with answer as our double. Let's just go ahead and set answer equals to the 0. I know it's already equal to 0 when it's initiated. I want to be explicit here and just say, NPV of cash flows starts at 0. So we're going to start at 0 and then start accumulating the value of each cash flow each successive time through the loop. So each time we're going to take answer and we're going to add to it. So we're going to take whatever answer was before, it starts at 0, and then plus the present value of each cash flow. So now we want the first cash flow. To get the first cash flow, remember our variable is called cash flows, so we have to be careful about that, make sure that that matches. And now which version do we want? Well, it's all in one row, so it's going to be 1, comma, and then which column do we want? Well, we want the first column because it's the first time through the loop. So comma I, because I is what's keeping track of columns for us. So we take that first cash flow, and now we have to discount it. So let's discount it by dividing by 1 plus our discount rate. We already have that in there, raised to the number of periods. So how many periods are we doing this? Well, because it's the first cash flow, it should be 1 period. So I comes in here again. So we've got our cash flow in period 1, discounted 1 period. So I is doing a lot of the heavy lifting in the math here. It's keeping track of which cash flow we want and how much to discount it. So we hit enter on that. We should get our answer that accumulates. Let's go ahead and see what that looks like. Oh, and finally at the end, let's actually, once we're done, we should just set our answer equal to what we return to the user. So let's flip back over to Excel and test it. So what we see is we get 46.10, right? We get the same answer we got from our NPV function. It looks like it's adding it up over time. However, that's not always what you're going to get the first time through. A lot of times you're going to get a value, either a value error, or you'll get a value that just doesn't match what you expected. So we have to be able to go troubleshoot it. So let's go see how we can troubleshoot. One way is we can use our debug print just with our answer value. All right, so let's see what happens when we do that. Notice we don't have anything in our immediate window right now. We come back over, run our function. Now we get our 5 sequential answers. And what we see here is that the first cash flow was worth $13 and about 4 cents. The first 2 cash flows together are worth $20. The first 3 together are worth $28, right? Sometimes that's what you're going to want to see. Basically, what's the cumulative total so far? Because remember, we're accumulating by always taking the previous value of answer and adding that new cash flow onto it. But sometimes it can be hard to keep track of. You don't want to actually do that mental math to figure out the differences. Instead, you might want to just see the present value of each individual cash flow. At that point, we can just take this piece of code, right, our actual calculation, and put that as our print value. Let's go ahead and see what that looks like now. We rerun things. And now we see the present value of each individual cash flow. That first cash flow is worth $13, then $7.56, $7.89, $9.15, and $8.45. And now if you're debugging your code, you can compare that to some actual calculations you do in your spreadsheet or with a calculator, however you want to do it, to actually figure out, is the code doing exactly what I think it should be doing in calculating each of these values? So debug.print with this immediate window is a really good tool to go back and check that the code is actually calculating how you think it should be calculating. Now the last thing I'm going to add here is a second version that actually takes the annoying feature of the Excel NPV function and gets rid of it. Right? That annoying feature is the fact it doesn't ever take into account time zero cash flows. Because in this case, we have a bunch of positive cash flows, but to truly be a net present value, well, we need to take out this $25 of negative of investment at the beginning. So what we're going to do is we're going to create a second version, v2 of our function. Let's make some room for it. And we're going to allow for an optional argument here. So first I'm going to go through and update to v2, right, making sure my output is the same as my function name. Now I'm just going to add one more line here, optional initial CF as double. So now I have an initial cash flow as a possible argument to add in as well. And now the coding is actually almost exactly the same, right? To the present value of all those other cash flows stays the same. All we got to do is add in the time zero cash flow. And because we don't have to discount it at all, we can just directly add it in. So I'm going to put initial cash flow there. So if initial cash flow isn't input by the user, it actually won't mess up our function. Because if this variable does not get input, its value is going to be 0, and it's not going to throw off this answer. If you do input it, though, it'll actually augment that answer and take into account that initial cash flow. So let's see how that works once we copy this over. All right, we're going to come in, again, make our change to v2. And the last thing, let's just see what that looks like. We get the same answer, so that's working pretty well. Now we can come in and actually select that initial cash flow as our optional argument. And now we see the NPV is adjusted down by $25, and now it's actually an NPV. Before we would say that was a present value because it's only taking into account those future cash flows and not the investment at time 0. So now we've corrected the Excel NPV function and made an NPV function that actually takes into account time 0 cash flows.